This tutorial is designed to go along with quiz A from chapter 21. So you should either have it next to you looking at it, or you should have kind of already spent time working on it. And this is sort of a walkthrough with how you should attempt to complete this this quiz from chapter 21. It basically talks about a company manufactures chips. They find that 8% of all their chips are defective. So that's kind of your idea for your null hypothesis. They're concerned that the employee inattention is partly responsible for the high defect rate. In an effort to decrease the percentage of defective chips, management decides to offer incentives to employees who have lowered defect rates on their shifts. The incentive program is instituted once a month. If successful, the company will continue the incentive program. So let's ask for a minute. The first question says, write the null and alternative hypothesis. Well, I think it's real easy to write the null. That was pretty obvious. So my null hypothesis is obviously, since they gave us the 8%, my null is going to be P equals 0.08. Always write it in terms of the decimal, because P is a proportion, not a percentage. So the defect rate is 8%, so therefore I'm going to assume that the effect present, now the effect that they're wanting to do is if we do this initiative, we're hoping to decrease the defectiveness, because that's the whole point of the incentive program. So that's the absence of that would be that the defect rate would stay the same. So in that light, it allows us to think about our alternative, because we want to say that the effect that we're looking at actually does take effect, and so we would say that our P would be less than 0.08 if it works, because that's what we're going to be looking at. If the incentive program works, then in fact their percentage or their defect rate would go down. All right. Number 2. It says, in context, describe a type 1 error and the impact such an error would have on the company. Okay, remember, type 1 error would be where that you decided that the percentage of chips decreased when it didn't. Okay, that's where if you rejected the null, but it really was true. Okay, so type 1, and this is, I'm not going to dwell a whole lot on type 1 and type 2 errors, because that's a pretty complex topic, and I'll explain a whole lot of that when I get back. The best way I've explained type 1 and type 2 errors is in the case of the courtroom. So I'll just tell you that now. The null hypothesis is that when you walk into the courtroom, and we talked about this, is that you're innocent until proven guilty. So HO is defendant is innocent. Okay, the alternative is that they're not innocent. And that's a little bit different than guilty, because we didn't actually prove that they were guilty. We just showed enough evidence so that everybody thought they were guilty. So that might have been proof, that might not have been. So that's kind of where you go with the not innocent type verdict for this case. So let's assume that the null hypothesis, in type 1 errors, the null hypothesis is true. In your book, they have that little square. Let's see, it's on page. So I'll also put that in my video. If you didn't write that down, you probably saw it in your book. Quite valuable. That's probably the easiest way to tell the different pieces apart. So if I make a type 1 error, the null hypothesis is true. So in a courtroom, that means the defendant actually is innocent. So if I make a type 1 error, I've convicted an innocent man. Okay? In a type 1 error, the null hypothesis is always true. So the way I make a mistake is by saying that it is false. A type 2 error is just the opposite. The null hypothesis is actually false, but I say that it's true. And so in the idea of the courtroom, it's when you let a guilty man go free. So you said type 2 error would be to say that you believe that the null hypothesis is true when in fact it's actually false. So they may even talk about that in the book. I don't remember if it's a courtroom or not. Another example would be to, let's say that you work for NASA and that you work on the space shuttle. A type 1 error would be to say, let's say that your job is to be responsible for saying everything is go for launch or not. And so you get in and it's countdown time and it's going, and your null hypothesis is that everything is okay. If something is wrong, then you reject your null and you stop the countdown. So the person who's responsible says, stop, there's something wrong, we have to cancel the countdown. But it turns out that he was wrong. And so, no big deal. They everything is fine. So he made a mistake. It really was true to start with, the way it was. His null was true. And so he'll just start back again. Other side of that is that something actually is wrong, but he does not fail to stop the countdown. The space shuttle goes up. Something terrible happens, and bad things happen after that. But those are some examples of type 1 and type 2 errors, and I'll spend a lot more time talking about that in person. I don't want to do a lot of that on the video. Anyway, so the type 1 and type 2 error for this context is that the type 1 error would be deciding that the percentage of defective chips has decreased when it has not. So we would say, yes, okay, percentage has decreased. I'm shortening this. But it has not. Let me erase that. Type 2 error. It's kind of just the backwards of that, where you say, no, the percent has not changed. And basically what we're saying here is that no, that hasn't changed, my incentive program's not working, when in fact it actually has. But the program works. I apologize for my really sloppy handwriting, but it's really hard to write on this thing. No, percentage has not changed, but the program works, and it actually has been working. So we have the type 1 and type 2 errors. Now, how you tend to work on that, it's going to be so this would be 1, but that's number 1, and if we talk about, for number 2 and number 3, just kind of what the effects are, the company, let's just suppose that they make a type 1 error, that the company would waste money on that program because they believe that it does work. So they're going to spend money on that program and keep it going, and they're going to waste money when they really haven't lost any, or haven't changed their defective chip rate. It's still 8%. Type 2 error, they're going to say, no, it's not working, so we're going to cancel the program, and they would miss an opportunity that they could decrease their rate of defective chips. Okay? I didn't write that down, but I don't really have a lot of space. Okay, so the next part, number 4, says based on the data they collect during the trial program, management found that 95% confidence interval for the defective chips was 5% to 7%. What conclusion should the management reach about the new incentive program? All right. So this is number 4. Well, 5% to 7%. Remember, my HO was P equals 0.08. So 8%. Well, do you see 8% in your interval? You would say no. So you're not willing to believe that the percentage is actually 8% anymore. Okay, so you would conclude that there is evidence. You can't even read that. There is evidence that the program is working. Well, we know that because we're 95% confident that the true proportion falls between 5% and 7%. So no matter where that falls in between there, it's lower than what it was to start with. So because they're working on this halfway through their little program or their study, then their percentage rate has dropped, or you believe that it has dropped. So this would be the same thing as rejecting your null in favor of your alternative, because the percentages don't fall that way. Number 5. It says, what level of significance did the management use? Well, this is tricky. They're referring back to number 4. So anytime that you use a confidence level, a picture will be most useful here. Confidence intervals are always two-sided. And we know that 95% was here. Now, we know that if I add up this area and this area, I'm going to get a total of 5%. But my alternative, HA, I forgot my O. HA is equal to, or is P, is less than 0.08. Oops, 0.08. And so, what we're going to say is, that is not two-sided, is it? It's less than. So we're going to have to say, well, even though my confidence interval was two-sided, I'm going to take this, and how much area is just in one of my tails? And that's easy enough. It's half of 5%, so the little magical formula for your alpha level is this. It's 1 minus your confidence level, 1 minus 0.95, or the area in the middle, divided by 2, which is equal to 0.025. So that's the the level of significance, or the alpha level that they decided to use. The tricky part is that you have to go from what they did in part 4 with a confidence interval, but it's only the null hypothesis they used was only a one-sided test. If they had been not equal to, then it would still be 5%, because not equal to is just like a confidence interval. It's two-sided as well. Okay, rather than putting half the area on one side and half on the other side. Let's see. Number 6. Describe to management an advantage and disadvantage of using a 1% alpha level of significance instead. Well, if I increase my alpha level, it makes it more difficult to reject my null. So I would be less likely to conclude. That is not conclude. I would be less likely to conclude that the program works. Okay, that would be an works if it really were not working. So what this means is if I decrease alpha, and at this point, if you haven't connected this yet, that means you haven't read the chapter, but if you haven't connected the alpha level to the type 1 error, they're exactly the same thing. So you could rewrite this wouldn't be in context, but you would be less likely to make a type 1 error. Okay, the disadvantage of decreasing it, you would have less power to detect a positive effect in the new incentive program. If you haven't read the chapter, power is one of those topics that seems like it's difficult to understand. Type 1 error and alpha levels always add up to 1. Type 2 error and power always add up to 1. There's not exactly a connection between type 1 and type 2 errors, but if you decrease type 1, you increase type 2 errors. So they're inversely related. There's not a direct connection. It's not a I add 1 here, you add 1 there kind of thing, but don't worry about the power. That's another thing I'll explain when we get back. So the disadvantage here is that you would have less power on this, because if I decrease my alpha, that means I'm increasing my type 2 error, which means I decreased my power, and that's probably just went over most of your heads, but don't worry about it. Let's go on to number 7. Management decided to extend the incentive program so that decision can be made on 3 months of data instead. Would the power increase, decrease, or remain the same? Well, what we're doing is that we are increasing sample size. And that's always a good thing. If I increase my sample size, I reduce my type 2 error. I also reduce my type 1 error. And I increase my power. So increasing the sample size increases power. Always. There's an easy question for you. Number 8. Oops. Over the trial month, 6% of computer chips manufactured were defective. Management decided that this decrease was significant. Despite this, management might choose not to permanently institute the employee incentive program. Why? Now, this is a logical, just what do you think in terms of your own experience and things like that. There's not a lot of math behind this part. Remember that statistical significance isn't always practical significance. I mean, in other words, I might show that statistically it does have some value, but it might not be practical for me as the manager of the company to implement it. For example, if the incentive program is extremely expensive, then I may conclude that although it decreased my profit or my defective chips, it didn't decrease it enough to increase my profit margin to justify the program. And that's plain and simple. That's all you really have to say there. So I guess the mathematical answer you're looking for is this. Although statistically significant, it's not practical. Okay, program is too expensive. And so it's just not profitable in that scenario to do that. Now I know this stuff is definitely, this is what I was talking about, that gets really hard to understand, and I feel really bad that I'm not there. So we'll spend a lot of time going through some examples like this, but hopefully you can go through that and do your best Definitely read the chapter. And please send me emails. No one has hardly sent me any emails, so that means you're either not doing anything or you're not asking for help. I don't know. I can't help you either way. So, take some time and study up.